Hi everyone, welcome back. In today's class, let's see how to prove the given trigonometrical identity. Now let's prove this identity. Tan A plus cot A is equal to sec plus cosec A. So first consider the LHS. The LHS is tan A plus cot A. So we know that tan A is sin A by cos A. Sin A by cos A plus cot A is cos A by sin A by the quotient relation. We know the quotient relation. Tan A is sin A by cos A and cot A is cos A by sin A. Now the LCM is cos A into sin A upon cos A sin A. The first term will be sin square A plus the second term will be cos square A. So here how we get sin square A plus cos square A is that, so you need to divide the LCM by the denominator into numerator. This is what we do in each step when you take the LCM. Here the LCM is cos A sin A divided by the denominator is cos A for the first term, cos A into the numerator is sin A here. Sin A. So cos A cancels. You get sin A into sin A is sin square A. This is how we got the first term sin square A here. If you are considering the second term here, when you are taking the LCM, you get LCM is cos A sin A by the denominator is sin A here into the numerator is cos A. Sin A cancels. So cos A into cos A is cos square A. This is how we got the second term here. So you have to take the LCM and find out the terms you are obtaining in each place. That is sin square A plus cos square A. And as per the relation, square relation, we know that sin square A plus cos square A is 1. So we can write this as 1 by cos A into sin A. Square relation is sin square A plus cos square A is equal to 1. Now let's split and write this. This can be written as 1 by cos A into 1 by sin A. What is 1 by cos A? As per the reciprocal relation, we have seen that 1 by cos A is sec A and 1 by sin A is cosec A. That is what the result we need to get for the RHS, that is sec into cosec A. We got the same result, sec into cosec A. Therefore, we can say that tan A plus cot A is equal to sec A into cosec A. Tan A plus cot A is equal to sec A into cosec A. That is LHS equal to RHS. This is how we have to prove the identity. So you need to remember three things. The first one, whenever you get any identities, start with your LHS and you can use your trigonometrical identities or the relations and simplify and reach to your RHS. This is the first way of proving an identity. Start with the LHS, use the relations and reach to the RHS. Or you can start with your RHS, use your trigonometrical relations and come to the LHS. You can reach to the LHS. This is the second method of proving an identity. And if you are not obtaining in those two ways, what you can see is you can consider the LHS, reduce your expression on the LHS and you can consider the RHS, reduce it into the expression. Then you can see that both LHS as well as RHS you are reaching to the same result. In that way also you can prove the trigonometrical identities. Always remember, when you are considering one particular side, consider the side where more complicated terms are there and you can reduce that and reach to the other side. This is how you can prove the trigonometrical identities. Consider this question. Cos to the power 4a minus sin to the power 4a is equal to 2 cos square a minus 1. So we have LHS as well as the RHS here. As I have told you, you consider either LHS or RHS and simplify. Let's consider the LHS. Cos to the power 4a minus sin to the power 4a. So this can be written as cos square a the whole square. So that becomes cos to the power 4a minus sin square a the whole square. That is equal to, so this is in the form a square minus b square. What is a square minus b square? That is a plus b into a minus b. So this becomes cos square a plus sin square a into cos square a minus sin square a square minus b square, that is a plus b into a minus b. So here in the place of a we have cos square a, in the place of b we have sin square a. Now cos square a plus sin square a we have seen that is equal to 1 into cos square a minus sin square a. That is equal to cos square a minus sin square a can be written as 1 minus cos square a, and that is, see, we have seen that sin square a plus cos square a is equal to 1. That is the reason we have written the value over here, and here if you are finding sin square a, that will be 1 minus cos square a. So in the place of sin square a, here we can write 1 minus cos square a. Now just multiply with the negative sign inside, you get this as cos square a minus 1 plus cos square a. This implies cos square a plus cos square a is 2 cos square a minus 1, and that is the RHS what we need to get. That is equal to RHS. Therefore, we can say that cos to the power 4a minus sin to the power 4a is equal to 2 cos square a minus 1. Look at the next question. Sin a by 1 plus cos a plus 1 plus cos a by sin a is equal to 2 cosec a. Let's consider the LHS here. So sin a by 1 plus cos a plus 1 plus cos a by sin a. First let's take the LCM of these two. So you get this as 1 plus cos a into sin a. That is the denominator or the LCM. Upon that we can write, as I have told you in the previous sum, how to take the LCM and multiply L by D into N for the first one. So the LCM is 1 plus cos A into sin A divided by the denominator is 1 plus cos A for the first term into the numerator is sin A. So 1 plus cos A and 1 plus cos A get cancels. Sin A into sin A is sin square A. So the first term you get as sin square A plus, in the second term when you take this, again the same procedure, 1 plus cos A into sin A is the LCM divided by the denominator of the second term is sin A into the numerator is 1 plus cos A again. So sin A get cancels. This becomes 1 plus cos A the whole square. 1 plus cos A into 1 plus cos A is 1 plus cos A the whole square. So we get this term as 1 plus cos A the whole square. Always remember, when you take the LCM of terms, you can use this particular step. L by D into N. L is the LCM, D is the denominator and N is the numerator. So you get the terms what you need to write in the place of each term here. So this is equal to sin square A plus 1 plus 2 cos A plus cos square A divided by 1 plus cos A into sin A. So here I have expanded this as a plus b the whole square. So what is a plus b the whole square? A square plus 2ab plus b square. Now when you simplify, you get this as sin square a plus cos square a is sin square a plus cos square a plus 1 plus 2 cos a divided by 1 plus cos a into sin a. And as we know, sin square a plus cos square a is 1. We can write this as 1 plus 2 cos a divided by 1 plus cos a into sin a. And that's equal to 1 plus 1, 2 plus 2 cos a divided by 1 plus cos a into sine A. Take 2 common. This will be 2 into 1 plus cos A divided by 1 plus cos A into sine A. Now 1 plus cos A and 1 plus cos A get cancels. You get this as 2 into 1 by sine A. And as we know, 1 by sine A is the reciprocal of cosec A. So we can write this as 2 into cosec A. And that is the RHS. So this is how we can prove the given identities. Whenever you prove any identity, you need to remember you have to use the relations of different types of trigonometrical ratios. That is the reciprocal relation, quotient relation and the square relation. Now these questions are for you. You can prove the given identities and let me know the answer. Ck minus 1 by ck plus 1 is equal to 1 minus cos A by 1 plus cos A. Sine to the power 4a minus cos to the power 4a is equal to 2 sine square A minus 1. Use all the trigonometrical ratios and the relation between the different ratios and then you can prove it. That's all for today. We'll meet in the next class with more sums on trigonometrical ratios. Thank you.